Genique. So now we are starting the transmission lines. Okay. So here we will discuss some of the important problems. Through this we will clear our concept. Okay. So come to this. So calculate the input impedance of a lossless line of the following lengths: lambda by 8, lambda by 4, lambda by 2 and lambda. So in this, the transmission lines, they will be asking the input impedance and the reflection coefficients. Okay, every time they will be asking these questions only. Okay, mostly. And the transmission lines topic is very simple. Okay, when compared to all other concepts in the EMT. Okay, so now, so like the transmission lines, so it is also similar to the what are the transmission lines? The transmission lines are also used for guiding the waves. Okay, so in transmission lines also the energy will be propagated. Okay, the power will be propagated in the form of voltage and current. But for the uniform plane waves, it will be like any general medium. It will be like any general medium. It may be a free space, it may be a dielectric, it may be a free space or a dielectric. So these are the lossless mediums. We won't go for the lossy mediums there. Okay, so what are the lossy mediums? The lossy mediums are mostly the conductors. So if you go to the conductor, what happens? The sigma by omega epsilon term will be very high. So sigma by omega epsilon term is very high, means there is no propagation of the EM wave. So that's why we won't prefer the conductors. We won't prefer the conductors for propagating the electromagnetic wave. So where we use the conductors for propagation of the energy. So wherever there is a current and voltage waves, so we will prefer the current will exist definitely in the conductor. The voltage also will be existing in the conductor. Okay. So that means what we can now say, we can say that the voltage and current waves only possible in the conductors. So that's why we have to go for the transmission lines. But when compared to the EM waves, the transmission lines will be operated at the lower frequencies. Okay. So if the frequency increases, there is some limitations on these lines also. Okay. So that's why if you observe this in transmission lines, so there are mainly two types. Here we will be having only the lossless lines only. Okay, we won't go to the lossy lines. Everywhere we will go to the best, right? So always we have to try to reduce the loss everywhere. Okay. So now here in this question, so before going to this question, come to this. In electromagnetic waves, we derived E of z comma t and h of z comma t. Here also in transmission lines, we derive V of x and I of x here. So here Z, we assumed that the electromagnetic wave is traveling in Z directions, and we are calculating the waves at some particular intervals. Here we won't talk about the time here. Similarly, whatever we derived for the EM waves, the same derivations, the analysis will be done for the same analysis will be done for the transmission lines. But in transmission lines, we used to observe the calculations and we used to calculate either maybe reflection coefficient or anything, okay, from the source point of view. from the source point of view. But here we will calculate everything from the load point of view. This is the from load. Okay. So always we have to calculate anything. We don't know where the source is, where the generator is. So we won't talk about the generator. But for the EM waves, we will start from the generator only. Okay. But here we will be analyzing from the load point of view. We won't talk about the generator there. So as we are getting the E of Z comma T and H of Z comma T, we will be also getting the V of X and I of X. These are the EM waves, EH waves. These are also called as VI waves. So the EM waves will be possible in the general medium, but VI waves will be possible only in conductors. Okay. So this thing is enough. So similarly, what we got, how we got the electric and E of Z comma T, H of Z comma T, we will also be having the solutions for V of X and I of X. Okay, including those terms will be including sine and cos, and here these terms will be including e power gamma z and e power j omega t, like that, e power alpha z, like that. But here we will be having sine and causes. Understand? So you have to differentiate these two like this. Okay, here we will get the e power j omega terms. It is also harmonic. Sine and cos, they are also harmonics. The solutions of E and H are in terms of e powers, exponential, complex sinusoids. Here only the sinusoids. Okay. So now so how the transmission lines will be? Let us suppose it is a transmission line, it is a generator, it is a source. For the source, there must be a harmonics, time harmonic source must be there to generate an EM wave. Similarly, here also Vs and Is, where Vs is equals to V0 or Vm sine omega t must be present, and Is is equals to Im sine omega t must be present, because for generating an EM wave or VI wave, there must be a time harmonic source must be present at the one end of the medium. Let us suppose it is the time harmonic source. The source, it is what? Harmonic, time harmonic source. Okay, so it is connected to this line. It is entire thing is called as a line. Now here the load is connected. Here it is, load is connected. It is ZL. Okay, it is called as a load. Already I said we will be calculating any parameter from the load point of view. Okay, let us suppose the length of the line is L. The length of the line is L. It is the source. It is the source and it is connected to this. Let us suppose I am writing with this source as a black pen. Okay. So this is, it is the length of the line L. I am representing this. It may be 100 kilometers, 1000 kilometers, won't bother. Okay. So because I am analyzing my parameters from the load point of view, so I am naming this here at x equals to 0. If it is x equals to 0 means what? It is at the load. X equals to 0 means what? At the load. Okay. Here I am naming this is x is equals to L. Here x is nothing but what? It is x is a distance parameter. Okay, x is equals to the distance from the load, where x equals to what? X is nothing but what? I am naming this one as distance from the load. That is what v of x, I of x. The v of x is nothing but v at any x, means the v at any distance from the load. Okay, from the load. X is distance from the load. If x equals to load means we are calculating at load only. At x equals to L means we are calculating at what is the length of the line? L means we are calculating at the input. Anything. We are concentrating at the input, at the source. So this much is enough. So for this, we will be having, it will generate an EM wave, a VI wave, and it will be having the voltage and current waves. The voltage and current waves V of x and I of x are given as, it is cos h gamma x, it is equals to ZL cos h gamma x plus ZL cos h gamma x plus IL into Z naught sin h gamma x. Similarly, we will get ZL cos h gamma x plus VL by Z naught sin h gamma x. So we will be having this kind of, so I am not writing this entire, but yes, VL, sorry, here. Okay, these are the VI wave equations at any distance from the load. So from this, if I write Z input impedance at any x can be written as V of x divided by I of x. So here what is gamma? Gamma is equals to the propagation constant. What is gamma here? Gamma is equals to R plus J omega L G plus J omega C. You have to note this. What is H? These are the hyperbolic functions. So we will get the solutions like that only. Okay. So this will be equals to, if you simplify this, you will be having Z naught into ZL cos H gamma x plus Z naught sin H gamma x. It is gamma, not R. Okay. Divided by ZL sin H gamma x plus Z naught cos H gamma x. So like this. Okay. So like this, you have to write Z naught into ZL cos H gamma x plus ZL cos H gamma x plus Z naught sin H gamma x plus Z naught cos H gamma x plus ZL sin H gamma x. Okay. So like this. So this is the impedance at any x. So this is called as impedance at any x. You have to remember this. It is called as impedance at any x. Okay. So this is what? Gamma. What is gamma? Gamma is equals to alpha plus j beta. Understand? So now, I think this is over. Then what is Z? Z naught. Here ZL is equals to load. Here Z naught equals to characteristic impedance. What is the characteristic impedance? R plus j omega L divided by G plus j omega C. Okay, so like this. Suppose, now come to this. Now what happens? If ZL is equals to Z0, what happens? If ZL is equals to Z0, what happens? If ZL is equals to Z0, okay, what happens? ZL, Z0 equal, they will get cancelled, and numerator denominator is also cancelled. Then what happens? Then Z of X anywhere is equals to Z0, where if ZL is equals to Z0. Understand? And before this, what if Z of X at X equals to L? Z of X at X equals to L, what it will be? That means X equals to L means what? X equals to L means? X equals to L means what? It is at here, right? It is X equals to 0. It is the load. So this is X increasing direction, X increasing direction, X decreasing direction. So at X equals to L, what it will be? The Z at input, it is called as Z at input. So suppose if you put X equals to L, that is called as Z at input. So that means if you put ZL is equals to Z0, what happens? Z at anywhere will be is equals to Z0. That means what? Z in is equals to Z of X is equals to ZL is equals to what? Z0. This is called as what? This is called as a matched condition. What is? This is called as a matched condition. If you make this one the simple, if you make ZL is equals to Z0, okay, if you bring any load which is equivalent to the Z0 of that line, okay, that will make all this equal. That means the impedance anywhere on the line will become same, that is equivalent to Z0. This is called as what? The matched condition. Okay. So this thing. Now come to the what is a lossless line? Already we know what is gamma. Gamma is equals to alpha plus j beta. So if it is lossless, it will be 0 for lossless. So this implies what is gamma? Gamma is equals to j beta only. So lossless, for lossless means it is a purely imaginary. The gamma will be purely imaginary. That is the meaning you have to know. If gamma is purely imaginary, then that is called as a lossless line. Okay. If gamma is purely real, then it is a purely lossy line. If it is a mixed version, means complex, it is any general medium. It is neither lossless or lossy, in between. Now observe this. What is Z of X for a lossless line? For a lossless line, what it will be? Z of X will be is equals to Z0 ZL cos H J beta. Suppose this is, I am finding Z in. I am finding the Z in. Okay. I am finding the Z in. No need to write. Okay, directly you can write. Z of X equals to beta X plus Z0 sin H J beta X divided by Z0 cos H J beta X plus ZL sin H J beta X. Understand? So this is for a lossless line. You should know that sine h theta is equals to h j theta is equals to j sin theta. You should know that cos h j theta is equals to cos theta. Okay. So if you know this, the entire thing is same. So from this, what can I write? So z of x can be is equals to z naught into what? ZL cos j beta x, ZL cos beta x, ZL cos beta x plus j z naught sin beta x divided by z naught cos beta x plus j zl sin beta x. So this is z of x. Suppose what we have to find? So this is z of any x for a lossless line. This is for what? It is for a lossless line. You have to remember this. Now, if I want to calculate the input impedance, so for finding input impedance, what is x equals to? For finding input impedance, the x equals to what? X equals to L. Okay? If x is equals to L, z of x will be is equals to z in. So from this, z in can be written as what? Z naught into ZL cos beta L plus j sin beta L. Okay. J z naught sin beta L divided by z naught cos beta L plus j zl sin beta L. Okay. So like this. This is the input impedance expression for any lossless line. Okay. This is called as the input impedance expression for any lossless line. Now, observe this. So come to this. Suppose for the given question, okay. So if the length, what is the length? Here we have taken what is beta L. Here beta L. Beta L is nothing but it is called as L is the physical length. Beta L is called as 2 pi by lambda into L. This is called as what? This is called as electrical path length. Electrical path length. Now come to the first one. Here L is equals to what? It is a physical length. Already the length is represented in terms of the wavelengths. So it is our tradition to represent the length of any line or length of any antenna in terms of the wavelengths. Okay. So here L is called as a physical length. How it is physical? Really long. So beta L is called as the physical length. It is 2 pi by lambda. So here you will get what? The radians. For the units are what? Meters. Here the units are what? Degree or radians. The units are important. The beta L, 2 pi by lambda into L. Distance will get cancelled. 2 pi will be the radians. Okay. Degree, radians. Now come to this. First one. Now L is equals to given lambda by 8. Now from this, what is Z in? Z in equals to Z naught ZL cos. Then what is beta L? Beta L is equals to 2 pi by lambda. What is lambda by 8? L is lambda by 8. It will get cancelled. This is pi by 4. Cos pi by 4 plus j z naught sin pi by 4 divided by z naught cos pi by 4 plus j zl sin pi by 4. Psi pi by 4 is 1 by root 2. Okay, so here you will get Z0 into root over ZL plus JZ0 divided by Z0 plus JZL is the input impedance. So it is very well known result. It is very well known result. So that's why we have chosen this problem. For these lengths you have to remember these kind of expressions. So Zn for the lambda by 8 line. Now come to the second question. What is the second one? The second one is saying that is what is L is equals to lambda by 4. Then what is beta L? Beta L is equals to 2 pi by lambda into lambda by 4. This will be pi by 2 radians. Pi by 2 radians. So what is Zin? Zin for the lambda by, this is for lambda by 8. This is for lambda by 4 line. See, the length of the line is lambda by 4. What is lambda? Lambda is nothing but the wavelength. Okay, always the length is compared with respect to the wavelengths only. Okay. So this is equivalent to what? Z0, ZL. Observe this. So ZL cos beta L. Cos beta L is what? Pi by 2. So pi by 2, cos pi by 2 is ZL into 0 plus JZ0 into sin pi by 2, 1 divided by Z0 into cos pi by 2, 0 plus JZL sin pi by 2, 1. How much you will get? It is Z0. What about this? JJ will get cancelled. Z0 square divided by ZL. This is Zin for the lambda by 4 line. It is called as Z0 square by ZL. It is also called as impedance reflector. It is called as impedance reflector. We will see what is impedance reflector later. Okay. Now come to the third one. What is the third one? The third one is what? L is equals to lambda by 2. This implies what is beta L? Beta L is equals to 2 pi by lambda into lambda by 2. This will be is equals to pi. So similarly what you will get? Zin is equals to, here you will get, what is the Zin expression? The Zin expression is, if you put pi there, Zin is equals to what? Z0, ZL cos beta L plus JZ0 sin beta L divided by Z0 cos beta L plus JZL sin beta L. If you put beta L pi, this will be 0, then this will be 0. Okay, cos beta L get cancelled, and Z0 will get cancelled. Zn is equals to what? ZL. So that means the impedance at the input is reflected as the ZL. So whatever we put the ZL at the input, so at the load, it will be appeared at the input. So this is called as, it is called as impedance reflector. What is impedance reflector? What is this? What is this? Lambda by 4 line is called as impedance reflector. Okay, this implies ZL is equals to Z means what? Lambda by 2 is what? Impedance. Sorry, it is not reflector, it is inverter. It is inverter. It is impedance reflector. It is impedance reflector. Okay. So like this. Suppose if you take ZL equals to Z, fourth question. Fourth one is, if L is equals to what? Lambda. This implies beta L is equals to 2 pi. beta L is equals to 2 pi. So Zn is equals to, again we will get Zl. Okay, these are the relations and we should remember. So wherever we find these kind of questions, and it will be easy for you. Suppose if there is any lines, so generally these known lines will be given, so that's why you have to remember these relations. Okay, next question. So this is the question. The question is, the options are okay. The question is, the nature of the input impedance of a lossless line with Z0 equals to 50 ohm of lambda by 8 length with the inductive load 50 ohm is. So here in this question we have to find the nature of the input impedance for the lossless line. Okay, which length he has given? It is a lambda by 8 length line is given. The length is given as lambda by 8 length. For the lambda by 8 length, what is the input impedance? The input impedance for the lambda by 8 line is Z0 into ZL plus JZ0 divided by Z0 plus JZL. You have to remember this for a lambda by 8 length. But how much he has given? Z0 is given. Z0 is equals to 50 ohms given. And ZL is also given. What is ZL? ZL is given. What is Z0 means? What? Characteristic impedance. Okay. So here ZL is equals to 50 ohm given. But you have to notice that it is an inductive load. You have to notice that it is an inductive load. It is not a resistive load. If it is simply has given it a load of 50 ohm, then it is a resistive load. If it is an inductive load means you have to write it is J50. That is the thing you have to observe. If you write only 50, it's gone. Total, the question is wrong. Suppose if it is a capacitive load, for the capacitive load, you have to write minus J50. It should be minus for capacitive. Understand? So now it is purely imaginary. Capacitive load means it is purely imaginary. Okay? And inductive load is also imaginary load. So now what is Zin? the Zn is equals to Z0 50 into Z0 is given. So J50 plus J into 50 divided by ZL is J50, Z0 is 50, J into 50. So it will be Z0 is 50 plus J into ZL is J50. How much you will get? Here it will be 50 into, it is what? J100 divided by 50 minus 50. 50 minus 50. Here you will get J square is minus 1. That means how much you are getting? Infinity. So what is infinity? The Zn is of which nature? Infinity. Means the infinity input impedance of the Zn is infinity. Means what? It is an open circuit nature. So this kind of questions you have to be very careful while solving this. Okay. So you have to notice which kind of load is it has given. Understand? So next.